Hello, this is my presentation for this week's interactive advanced concept of magnetic fluid. So first I'm going to start off by showing the video of my experiment. So I already weighed out about 10 grams of the ink and 10 grams of the vegetable oil, and I had mixed it up, put it in a glass with my earth magnet that I have here, and it's really hard to tell, I don't know if you can see, but the mixture is together and slightly viscous, but it wasn't exhibiting the ferromagnetic properties that I learned about. So that was a bit disappointing. I think it has something to do with the material that I use for this. So, so I used a rare earth magnet, vegetable oil, and ink. I used Epson inkjet printer refill ink. I knew that we needed about 50 milliliters. That's what was said in the videos that I observed. However, going back and looking at it, I couldn't find toner, and so I think I got confused with ink toner. So I used ink that was, I read that LaserJet ink had magnetic properties, so I found ink that had that, but I guess there wasn't enough magnetic properties in that to exhibit what we were trying to see here. So in hindsight, I should have tried to find toner, but it was hard to find, so I'm just going to move forward and explain what should have happened in the experiment. So basically, ferrofluid is tiny magnets suspended in fluid that react to the magnetic field. In this case, was the rare earth magnet around it. So sometimes the magnets are iron oxide and nanoparticles suspended in the fluid, and that the nanoparticles are tiny, tiny magnets that don't even settle at the bottom of their container. They're so small. In this experiment, the magnetic properties should have come from the iron oxide in the toner. They aren't magnetized when they're in the fluid because they're paramagnetic, which I'm going to get into a little bit later. But they're mixed in with the vegetable oil, and so that mixture has increased surface area, which keeps the particles from sticking together. And so in this experiment, you could consider the vegetable oil and the toner to be a ligand, the ligand being an ion or molecule that bonds to a central atom to form a shape. That's what we were learning about in this week's material. So, and it would react to the magnetic field around it, which in this case is the rare earth magnet, like I mentioned before. And so the rare earth magnet actually polarizes the nanoparticles, and that's how we get the polarization attracted to that magnet, is how we see the unique shapes of the experiment. So, as I mentioned, the nanoparticles are paramagnetic, meaning they're not magnetic when they are suspended in the vegetable oil together. They're not attracted to each other, but when they are in the presence of another magnet outside of each other, they do become magnetized. And so in this experiment, vegetable oil would act as a surfactant, and that allows the nanoparticles in the toner to remain separated from each other. And so this also has a high surface area that allows the fluid, when in contact to the magnet, maintain its shape. And another thing we can see here is van der Waals forces allow the molecules to maintain their adhesion as they move through the mixture. So if magnets were attracted to the earth magnet outside the glass, and when I moved it around, I should have been able to see the shape move, and that would be that van der Waals force as the adhesion. Another concept that we were reading about this week, the big concept, was the crystal field theory, and that kind of is applicable to this experiment in terms of the paramagnetic field. So the ions are affected by the energy of the d orbitals, and so the difference in the high and low energy of the d orbitals is what can change the property of the ligands and have a direct effect on its magnetism. And I read that high spin complexes are more paramagnetic than low spin complexes, so we would assume that the ions of the iron oxide in the toner would be a high spin complex. So this is what I should have seen through this experiment. It looks really cool, so I might have to try it again and find the appropriate materials just to play around with it. But so in conclusion, my fluid did not exhibit the magnetic properties that we should have seen in the ferrofluid. However, I still learned a lot about the concepts that are exhibited in the ferrofluid, so I still found it to be pretty cool, and thank you for watching.